Hello students, in today's class we are going to learn about the sum to n terms of some special series. We are learning chapter sequence and series. So far we have learnt about arithmetic progression. We have brushed up the concepts of AP which we have learnt in our previous class, and then we learned arithmetic mean, then geometric progression, then geometric mean, and also the relationship between AM and GM. So in today's class we are going to learn about sum to n terms of some special series. What is the first one? Sum to n terms of first n natural numbers, sum of first n natural number, and you should see all the series starts from 1, right? The formula is applicable only if it starts from 1. Okay, so this is sum of n terms, sum of first n natural numbers. The formula is n into n plus 1 by 2. This is sum of the squares of the first n natural numbers, 1 square plus 2 square plus 3 square etc., which is n into n plus 1 into 2n plus 1 divided by 6. And this is sum of the cubes of the first n natural numbers, 1 cube plus 2 cube plus 3 cube plus etc. n cube is n into n plus 1 divided by 2 the whole square. So if you see the relationship between sum of first n natural numbers and sum of the cubes of the first n natural numbers, can you find out the the relationship between these two? Yes, what it is? The square. If you square the sum of first n natural numbers, that will give you the sum of cubes of the first n natural numbers. Yes, hope you can make out. And the sum of the squares is n into n plus 1 into 2n plus 1 divided by 6. Now let us see how can we solve the problem using these three formula. Now the first question is, they asked you to find the sum to n terms of 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 etc. So if you analyze this, what will be the nth term here? This is, see, the first term is 1, 2, 3, 4, right? So it is n. Your nth term will be n into, and if the next term, if you see 2, 3, 4, so when it is 1, this is 2. So when it is 2, it is 3. When it is 3, it is 4. So it is n into n plus 1, right? This is what we need to find out, right? And hence it can be written as Sn of the given series is summation k is equals to 1 to n k into k plus 1. Hope you can follow this. We have written it in the short form. We know the symbol stands for summation, which means we need to add by substituting the values for the variable which we have used there till we reach the end value. So if you expand this, what you will get? If I put k equal to 1, it will become 1 into 2 first term. Summation and you have to put plus. When k equal to 2, it will become 2 into 3, your second term, plus. If we put k is equal to 3, it will become 3 into 4. Likewise it goes on till if I put k equal to n. K equal to n, what will happen? N into n plus 1. That will be our nth term. So this series we can write it in general as summation k is equals to 1 to n k into k plus 1, where k is any integer. You can use any other variable like r, t, anything you can use. Now this can be written as a summation k is equals to 1 to n. If we multiply, what we will get? K square plus k, right? K square plus k. This summation is for both, so we can split it. So this can be written as summation k is equals to 1 to n k square plus summation k is equals to 1 to n k, right? Now what is this summation k is equal to 1 k square, which is nothing but 1 square plus 2 square plus 3 square plus etc. till n square, right? This is nothing but 1 square plus 2 square plus 3 square plus etc. till n square. And this is nothing but 1 plus 2 plus etc. till n. So we know the formula for this. What is the formula for this? N into n plus 1 into 2n plus 1 divided by 6. Plus what is the formula for this? N into n plus 1 divided by 2. Right? Now take LCM and simplify it. We can take n into n plus 1 by 2 as common. So what is left out? 2n plus 1 divided by 3. We have taken 2 common, right? So plus we have taken entire thing as common, so this is going to be 1. So n into n plus 1 divided by 2, 3 LCM. So 2n plus 1 plus 3 ones are 3. So it is going to be n into n plus 1 divided by 2. Here it is 2n plus 3 plus 1 is 4 divided by 3, right? So this can be written as n into n plus 1 divided by 2. From here we can take 2 as common. So 2 into n plus 2 divided by 3. Everywhere under product, so these two will get cancelled. So it is n into n plus 1 into n plus 2 divided by 3 is the answer, is the sum to n terms of the given series. Right? Hope you understood. So this is the procedure to solve such a kind of problem. What you should do, first find your nth term, then try to express it in the general form and then bring it to the any one of these 3 forms. Then only we can apply the formula and then apply the formula and find your solution. We can give only in terms of n because they asked you to find sum to n terms only, right? Hope you understood. The same way, if you see the second question, the question is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus etc. So you can easily write what is this? Sn is equal to summation k equals to 1 to n. First term is 1, 2, 3, likewise it goes on. So k into. Second term is 2, 3, 4. So it is k plus 1. Third term is 3, 4, 5. So it is k plus 2. Right? So if you put 1, you will get 1 into 2 into 3. If you put 2, you will get 2 into 3 into 4. Likewise it goes on. Now as we did in the previous problem, first multiply this and then segregate it to get your notation in terms of your known results. So summation k is equals to 1 to n. If you multiply, first I am going to multiply this with this, right? So k square plus k into k plus 2. Now again I am going to multiply this with this term by term. K into k square into k, it is going to be k cube, plus k square into 2, it is going to be 2k square, plus k into k is going to be k square, plus k into 2 is going to be 2k. Now we can add these two since both are of k square. So summation k is equals to 1 to n k cube plus 3k square plus 2k. Kindly maintain the brackets because this summation is for the entire term. Alright. So now you can segregate. Summation k is equals to 1 to n k cube plus constant, we can take it out because it is independent of the k, right? So 3 into summation k is equals to 1 to n k square plus 2 into summation k is equals to 1 to n k. Now this is sum of cubes of the first n natural numbers. This is sum of squares of the first n natural numbers, and this is sum of first n natural numbers. You know the formula for all the 3. So if you substitute and simplify, you will get your answer. Yes, I am leaving the remaining part to you to complete it. Hope you understood. Now if you see the third question, it is 3 into 1 square plus 5 into 2 square plus 7 into 3 square, likewise it goes on. So if you analyze, it is clearly n square. The second term is n square. What about the first term? First term are all odd numbers, starts from 3. So if it is 1, it is 3. Normally odd numbers we will denote it by 2n plus 1. So you can give a try to check it. If it is 2n plus 1, if I put n is equal to 1, what it will be? 2 ones are 2 plus 1, 3 I will get. When n is 2, 2 2s are 4 plus 1, 5 I will get. If I put n is equal to 3, 2 3s are 6 plus 1, 7 I will get. So clearly this can be written as summation k is equals to 1 to n 2k plus 1 into k square. Hope you understood. These are all odd numbers. Odd numbers we will denote it by 2k plus 1, and this is k square, that particular number square. So 2k plus 1 into k square. Now again, as usual, we can multiply this. Summation k is equals to 1 to n 2k cube plus k square. You have to multiply term by term. Then split the summation. Summation k is equals to 1 to n 2k cube plus summation k is equals to 1 to n k square. We know the formula for this k cube. 2 is independent, we can take it out. And for k square also we know. For k square it is n into n plus 1 into 2n plus 1 divided by 6. And for this, n into n plus 1 by 2 the whole square. Right? Again, if you simplify it, you will get your answer. Yes, hope you understood. Now let us move on to our next question, which is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4. Likewise it goes on. So it is very clear what is your nth term. 1 by n into n plus 1. Right? 1 by n into n plus 1. Because the first terms are 1, 2, 3. The second terms are 2, 3, 4. So n into n plus 1. So Sn is summation k equal to 1 to n 1 by n into n plus 1. Now here is a thing where if we have the product of two terms in our denominator, we cannot split it. If we have it in the numerator, we can split it into two terms with the same denominator, right? Now in this case, how can you split this term? Even if we multiply, we will get n square plus n in the denominator, not in the numerator, right? So there is a method called partial fraction. There is a method called partial fraction. So we will decompose this into two terms. There is a method. Now let me explain you. 1 by n plus 1 is your question, and when you have two different factors in the denominator, you can write this as a by n plus b by n plus 1. This is a procedure of partial fraction. If you have 2 or 3 distinct factors in the denominator, it can be written as a by m, the first factor, plus b by the second factor. Now our aim is to find what is our a and what is our b. How can we find this? Now take LCM. This will become a into n plus 1 plus b into n divided by n into n plus 1. This side 1 by n into n plus 1. Both have same denominator. So we ended up with a into n plus 1 plus b into n equals to 1. This is what our equation. Now how can we find our a and b? Now you have to replace the values of n from these two factors. You find the roots of this equation and substitute it to find our unknown value. So what are the two roots here? N equal to 0 and n equal to minus 1, right? If I equate n plus 1 equal to 0, I will get n equal to minus 1. So let us put n equal to minus 1 and n equal to 0. So if n equal to minus 1, what will happen? A into minus 1 plus 1 plus bn equal to 1. So this will become 0. 0 into a is 0, right? And n is equal to minus 1. So in the place of n we have to put minus 1. So we got minus b equal to 1 or b equal to minus 1. We found the value of b now. So if n equal to 0, the other factor we are going to substitute 0 plus 1 plus b into 0 equal to 1. So this is a is equal to 1. This term will become 0. Thus we found the values of a and b. Therefore 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. Yes, I have substituted the values of a and b here. This is what the procedure of partial fraction. So if you have 2 or 3 distinct factors in the denominator, you can express it like this and you can find. If you have 3 distinct, you can write it as c by the third factor. Take LCM and find the values of a, b, c by substituting the values as the factors, the roots of the factors, right? So after getting this, now we will get into our problem. How can we solve it now? Once we find this, we can get back to our summation problem. Sn is summation k is equals to 1 to n, 1 by n into n plus 1. Now this can be written as summation k is equals to 1 to n, 1 by n minus 1 by n plus 1. Right? So this is nothing but summation k is equals to 1 to n, 1 by n. Summation k is equals to 1 to n, 1 by n minus summation k is equals to 1 to n 1 by n plus 1. Now what is this actually? 1 by 1 plus 1 by 2 plus 1 by 3 plus etc. up to 1 by n minus this is going to be 1 by 1 plus 1 is 2 plus 1 by 3. If I put n is equal to 1, the denominator is going to be 2. If I put n equal to 2, the denominator is going to be 3. Yes. So likewise it goes on till 1 by n plus 1. Right. If you see plus 1 by 2 minus 1 by 2 will get cancelled. Plus 1 by 3 minus 1 by 3 will get cancelled. So till 1 by n it will get cancelled. The first term 1 by 1 is 1. It is not getting cancelled, right? So 1 by n will get cancelled. The last term is minus 1 by n plus 1. So this is what we arrived at. Now take LCM. N plus 1 is your LCM. So n plus 1, this is minus 1. So plus 1 minus 1 will get cancelled. I have cross multiplied this. So we got n by n plus 1. This is what your Sn. Yes. Hope you understood. When you have a product of terms in the denominator, we cannot split it directly. There is a method called partial fraction. So I explained you that method here. Then after obtaining the values, you have to split and simplify to arrive at your answer. Hope you understood. Let us move on to the next question now. Now the next problem. 5 square plus 6 square plus 7 square plus etc. up to 20 square. They asked you to find the sum of this series. They didn't tell you to find 2 n terms. They asked you to find till this. We don't know how many terms are there. Right? How many terms will be there from 5 to 20? 16 terms, because 1 to 4 is missing. 5 to 20 is there. And if you see, it is 5 square, 6 square. And blindly you should not apply the formula that sum of squares here. Okay, you cannot apply sum of these squares here directly, because it doesn't start from 1 square. If it starts from 1 square, 2 square, if it starts from 1, then you can apply the formula sum of squares of the first n terms. Because here it starts from 5, you cannot apply the formula directly here, right? Instead, you can write this series as 1 square plus 2 square plus etc. plus 20 square. From this, if I subtract 1 square, 2 square plus 3 square plus 4 square, won't I get the required series? Yes or no? 1 to 4 square is missing. So I have added and subtracted that. Right? I have added and subtracted that. Now this also starts from 1. This also starts from 1. So I can apply the formula for both the terms. Yes or no? So this can be written as summation k is equals to 1 to 20. What it is? K square plus, minus, here it is minus, no, minus summation k is equal to 1 to 4 k square. Alright. What is the formula for summation n square? It is n into n plus 1 into 2n plus 1 divided by 6. Now our n is 20. So 20 into 20 plus 1 into 2n, n plus 1 into 2n plus 1. So 2 into 20 plus 1 divided by 6 minus, here our n is 4. So 4 into 4 plus 1 into 2 into 4 plus 1 divided by 6. Right? Now simplify this. This is going to be 20 into 21 into 2 into 20 is 40. So 41 divided by 6 minus 4 into 5 into 2 4s are 8 plus 1 9 divided by 6. Now we need to simplify this. So the next step is you need to simplify. So if I multiply, I didn't cancel because I kept the denominator as same so that it will be easy for our calculation part. So I multiplied all the numerator, it is 17220, here it is 180. If I subtract, I got 17040, then I have cancelled it. So our answer is 2840. So it all depends how are you analyzing your problem. So what we did here, the series didn't start with 1, so we have added the missing terms and then we have subtracted. So we have added and subtracted the same terms so that the value of the question doesn't change. But we have did all these manipulations in order to make our calculations easier, to apply our formula. Yes, hope you understood. The remaining problems I want you to solve, but still I'll give you the clue or the hint to solve it. If you see the next question, 3 into 8 plus 6 into 11 plus 9 into 14 plus etc. If you see the first terms, it are all multiples of 3. So the nth term, the first part is going to be 3n, right? 3, 6, 9. 3 ones are 3, 3 twos are 6, 3 threes are 9. So if I put 1, n equal to 1, I will get 3, n equal to 2, I will get 6, n equal to 3, I will get 9. So the first part is going to be 3n into, your next is, if first number is 3, I am getting 8. If first number is 6, I am getting 11 as my second number. 9, 14. So it is clearly the first number plus 5, right? So it can be written as 3n plus 5. So 3n into 3n plus 5 is the nth term of this question. 3n into 3n plus 5. Yes or no? If you apply n is equal to 1, you will get 3 into 3 plus 5 is going to be 8. So 3 into 8 we will get. If we put n is equal to 2, we will get 6 into 11. And if you put n is equal to 3, we will get 9 into 14. So your nth term here is 3n into 3n plus 5. So for that we need to find sum of n terms. So summation k is equals to 1 to n, 3k into 3k plus 5. Then multiply, split the terms, apply the formula and then find it. Yes. And if you see the seventh question, it is, see, every term is squares. So first term is 1 square, second term is 1 square plus 2 square, 1 square plus 2 square plus 3 square. So what will be your nth term? Nth term will be 1 square plus 2 square plus 3 square plus etc. up to n square. So that is nothing but n into n plus 1 into 2n plus 1 divided by 6. That is what your nth term. Because we know the formula for sum of squares of first n terms, right? So summation k is equals to 1 to n, k into k plus 1 into 2k plus 1 divided by 6. So again you have to multiply, split the terms, apply the formula. Here the nth term itself is n into n plus 1 into 2n plus 1 divided by 6. For that you need to find the summation again. Yes, hope you understood. And if you see 8, 9 and 10, they have given directly the nth term. For these problems we found the nth term and then we have applied the summation. Here directly they have given your nth term. For this they asked you to find the sum. So this is summation k is equals to 1 to n, k into k plus 1 into k plus 4. So what you should do? You multiply all the three terms and try to split the terms with the summation. Obviously you will get a term with cube, you will get a term with square and then you can apply the known formula there, then simplify it. The same way with the remaining two problems. This is summation k is equals to 1 to n k square plus 2 power k. And this is summation k is equals to 1 to n 2k minus 1 the whole square. This can be done by expanding this using a minus b the whole square. So you will get a square plus b square minus 2ab term. So using that this can be simplified. So I want you to do all these problems by your own, and if you have doubts you can ask me, right? So do these problems as homework and post it in the group without fail, and if you have any difficulty in solving the problem, immediately ask me, I will help you out to solve it. Thank you students.